Hello, this is the FAQ video for this week's learning about polar area and arc length and tangent lines. So I'm doing this after half of the students have watched the video, so I'm hoping that this frequently asked questions video will hit some of the ones the other half will have. So one question was about equations of tangent lines and two polar curves. And the question was when should we change into rectangular form for polar versus leave it in polar form? So my response to that is usually when it asks for an equation of the tangent line, that's when we want it in the rectangular form. So y equals something, or y minus something equals something. And then there were a couple of questions about indices, and that was the big one that I want to talk to you about today. And if you had a question about finding theta values of like inner versus outer loops or areas, something that overlaps, I would really appreciate if you would come to office hours and ask that question in person, because I'm not 100% sure what you mean, and I would love to see an example. So I am going to spend most of this video talking about how we figure out the theta or index values of our integral. So the theta values. So let's say that we wanted to find the area of one petal of this graph given by r is equal to 2 cosine 3 theta. So what we're going to do is we're basically, I won't draw that, I'll dashed line here and a dashed line here. What we really need is the starting theta value that will, when we plug theta in, will start us at 0 and then will take us around here. That is an arrow. And then this is the ending theta, so our final theta, where when we plug in theta, it takes us back to r equals 0. So what we're doing here is we're setting up the equation 0 is equal to 2 cosine 3 theta. And now you could be thinking about how, okay, well, cosine of pi halves is equal to 0. So how can I turn 3 theta into pi halves, basically? And that would be for, let's say theta is equal to pi over 6 then. Because then we'll have 3 divided by 6. That's a half, so we'll get back to pi halves. So then the next question is well, looking at the quadrants that we're in the first quadrant and the fourth quadrant, what versions of pi sixths should these be? And when I say versions, I'm talking about, well, pi 6 will make this r equals 0, but so will 3 pi sixths, so will 5 pi sixths, etc. So we want to be thinking about what version. Well, since this right here is our starting theta, this is going to have to be negative pi sixths, because it doesn't make sense for us to start off, have a starting value be bigger than this theta value. And this theta value, since it's in the first quadrant, is going to be pi sixths. So this one doesn't make sense to be just under 2 pi, because remember, when we integrate, we want to go from the smaller value to the larger value. Also, it makes sense to go from negative pi 6, because when we plug that in, we're going to start at 0, and when we keep going and keep going and keep going and plug in theta values from negative pi 6 to pi over 6, we are going to be tracing this part of the curve and nothing else. So let's do one more example. How do we find the indices? Let's say we are looking, we're going to again go to this petal And we're going to look at, okay, well, we need theta values such that when the starting theta here is going to take us around and come back to this ending theta. And we know that both thetas, when we start and when we end, r has to equal 0. So they have to be thetas, values of theta, such that 4 cosine of 2 theta is equal to 0. And when we do a little bit of math, we're going to plug in, we're going to say, okay, well, that's pi fourths and versions of that. But again, here, the starting one, this is going to be negative pi fourths, and we're going to go 2 if we start at negative pi fourths, that will be at 0. If we keep going towards pi fourths. And a way we can check is actually, well, what happens when theta is equal to 0? Plug in to our r. Cosine of 0 is 1, so r is going to equal 4. So that's going to get us this point out here. So that's how we know we're tracing along this way. So that's a quick check. We need to be using our intuition to check the different versions of the indices. That makes sense. If we started at like 7 pi fourths, then we might be moving backwards, because if we're going from 7 pi fourths to pi over 4, well then this is bigger than this, and we would have to flip the indices, and we'd be tracing the area that is in red over here that we don't want. So that would be a no-no. And that's how we're just thinking about that. All right, that was your frequently asked question. That was the big one. So if you've got other questions that I didn't address, please come to office hours and ask, because I'm not addressing them either because I feel like we've talked about it in class together, or because I didn't know what you meant. So come talk to me. And, obviously don't forget to hit the like button, the subscribe button, etc., etc. Hope you're having a great day. Goodbye.